Hi, my name is Griselda and today's video I'm going to present with my classmate Julio the simple random sample. Let's start with its definition. The simple random sample is a subset of a statistical population in which every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. This method is the most straightforward of all the probability sampling methods since it only involves a single random selection and requires little advanced knowledge about the population because it uses randomization. Let's mention some characteristics. The first one is that a simple random sample is the easier method and uses randomization. This is the main characteristic that we can deduce by its name, simple random sample. The second one is that it takes a small random portion of the entire population to represent the entire dataset, where each member has an equal probability of being chosen. That means that even if the sampling must be small, any member has the same possibility to be selected. The third one is that researchers can create a simple random sample using three techniques. The first one is the lottery method, that is also called the hat method. In this one, you have to number all the members of your population, then you have to write all numbers in slips of paper, fold and put them into a container or a hat. Then shake the container to finally take the number of slips you need for your sample. The second one is the use of a table of random numbers. But how to use a random number table? I'm going to explain you by using this table. To start with, let's assume you have the test scores for a population of 20 students. Each student has been assigned a number from 1 to 20, and we want to randomly sample only 4 of the students for this demo. So since the population size is a 2-digit number, we will use the first 2 digits of the numbers listed in the table. So without looking, we have to point to a starting spot in the table. So let's assume we land on 75636. That is the third column, second entry. This location gives us the first 2 digits to be 75. This choice is too large because we have a population of 20. So we choose the next number in that column. We have to keep in mind that we're looking for numbers whose first 2 digits are from 1 to 20 that are representing the students. So the second choice gives the first 3 digits to be 40. Number 40 is still too large, so we continue down to the column until we find the last 3 numbers whose first 2 digits are less than or equal to 20. From this table, I arrive at 7, 3, and 4, and 5. So the result is that the students 7, 3, 4, and 5 will be used for our random sample. The third method is the random number generator. For this method, you have to type on the internet random number generator. Choose any page you like the most. I show this one as an example. Here I type the numbers from 1 to 20, that is my population. Then I type 4 because I want a sample of 4. And then the page automatically will choose the 4 numbers. Now let's continue with the last characteristic, which says that any research performed on this sample should have high internal and external validity. Internal validity is the extent to which you can be confident that a cause and effect relationship established in a study cannot be explained by other factors, while external validity is the extent to which you can generalize the findings of a study to other situations, people's settings, and measures. In other words, it means that if you apply the findings of your study to a broader context. I will continue by explaining the room for error. With a sample, random sample, there has to be room for error represented by the plus and minus variance, that is sampling error. A sampling error is a statistical error that occurs when an analyst doesn't select a sample that represents the entire population of data. As a result, the results found in the sample don't represent the results that will be obtained from the entire population. For example, in a high school of 2,000 students of a survey were to be taken to determine how many students are left-handed. Random sampling can determine that 8 out of 100 samples are left-handed. The conclusion will be that 18% of the student population of the high school are left-handed, when in fact the global average will be closer to 10%. The only way to have a 100% accuracy rate will be to survey all 2,000 students, which, while possible, will be impractical. Now, let's talk about the advantages of simple random sample. Firstly, the first advantage is that there is the ease of use represents the biggest advantage of simple random sample. Unlike more complicated sampling methods such as stratified random sampling and probability sampling, no need exists to divide the population into subpopulation or take any other additional steps before selecting members of the population at random. Then we can say that this method is representative, that there is an equal probability of selection. Also, the selection of members doesn't affect each other, and the last one is the lack of bias. A simple random sample is meant to be unbiased representation of a group. It is considered a fair way to select a sample from a larger population, since every member of the population has an equal chance of getting selected. On the other hand, we have the disadvantages of a simple random sample. The first one is that a sampling error can occur with a simple random sample if the sample doesn't end up accurately reflecting the population it is supposed to represent. For example, in a simple random sample of 25 employees, it will be possible to draw 25 men, even if the population consists of 125 women and 125 men. Another one is that if the researcher knows little about the population, he or she can only use simple random sampling. If the researcher knew more, it would be better to use a different sampling technique, such as stratified random sampling, which helps to account for the differences within the population, such as age, race, or gender. But for the contrary, the researcher can only use simple random sampling. Other disadvantages include the fact that for sampling from large populations, the process can be time-consuming and costly compared to other methods. That means that you will waste more time and money. Let's remind you something. Although simple random sampling is intended to be an unbiased approach to surveying, sample selection bias can occur. It is a type of bias caused by choosing non-random data for statistical analysis. The bias exists due to a flaw in the sample selection process where a subset of the data is systematically excluded due to a particular attribute. When a sample set of the larger population is not inclusive enough, a representation of the full population is skewed and requires additional techniques. I will finish my participation with an example of a simple random sample. It will be the names of 25 employees being chosen out of a hat from a company of 250 samples. In this case, the population is all 250 samples, and the sample is random because each employee has an equal chance of being chosen. Random sampling is used in science to conduct randomness and control tests or for blinding experiments. Thank you.
Hello, I will continue with the simple random sample, and to better understand this sample, I would like to highlight the work of the American Community Survey, the ACS. They help local officials, community leaders, and businesses to understand the changes taking place in their communities. And in order to do that, they use the simple random sampling. But they are officials from the United States Census Bureau, and they, let's say, when they are working with a community, they would follow a random selection of individuals just, let's say, for a year to ask random questions about their lives or about something specific. And in order just to draw a conclusion about the whole population, they will be testing. So they won't be taking each of member of this population, because there will be a huge amount of people, but they run a random selection of them. Now that we understand the advantages and disadvantages of this sample, we might ask ourselves when to use the simple random sampling. Well, I will be sharing with you some of the cases of the ACS investigations and their use of the simple random sample. We need to recall that this sample is used to make statistical inferences about a population. It helps to ensure high internal validity data. This is because randomization is the best method to reduce the impact of potential confounding variables in the future with your investigations. So you will be retrieving an accurate data. In addition, with a large enough sample size, a simple random selection has high external validity because it represents the characteristic of the larger population, as I was mentioning. Remember that we need to choose a considerable amount of people in order to be able to retrieve the good amount of data, of the accurate amount of data that we need to have for our investigations. Although it might sound easy, simple random sampling can be challenging to implement in practice. To use this method, there are some prerequisites that we need to take into consideration. You need to make sure that you have a complete list of every member of the population. This includes names, phone numbers, email addresses, and even physical addresses, because you will have to contact or access each member of the population if they are selected. You will use all resources in order to get in contact with them, because you will need to have the information. You will need to have the response of each member that has been selected for this investigation. So if they are selected, it's because they will be taking part of your investigation. You need to make sure of that. And also, you have to have the time. It is a must that you have the time and resources to collect data from the necessary sample size. So you will need to be wise when choosing your time and the large of population that you will be testing. You must use this simple random sampling when, well, it works better if you have a lot of time and resources to conduct your study, or if you are studying a limited population that can easily be sampled. That's why I was mentioning that you need to be wise when choosing the time and the number of the population that you will be testing. We know now that when to use it, but can you think about how can we perform a simple random sampling, or when would be wise to use it? To answer this question, there are 4 key steps before selecting the sample that you need to consider. Number 1, it is that you need to start by deciding on the population that you want to study. You will need to decide the amount, but also how is the population? What is the population? What are their characteristics? As previously mentioned, it's important to ensure that you have access to every individual of this population, so that you can collect data from all of those who has been selected for the sample. Also, in the step number 2, you need to decide on the sample size. As I mentioned, you need to decide how large your sample size will be. Although larger samples provide more statistical certainty, they also cost more. And require far more work. So you also need to bear that in mind. If you have a lot of people to investigate, you will need to spend a lot of money and time and resources. So keep that in mind. There are several potential ways to decide upon the size of your sample, but one of the simplest involves using a formula with your desired confidence interval and confidence level, estimated size of the population you're working with, and the standard deviation of whatever you want to measure in your population. So you can use even simple size calculator to estimate necessary sample size. There are a lot of in the internet. There are also some of them in the Microsoft Excel just to retrieve these random numbers. An example of the sample size that the ACS follows is that, for example, they investigate 3.5 million households each year. And this is just a small fraction of the overall population of 128 million households that there are, but it is a larger enough sample size to gather detailed data in all geographical regions and demographic groups in the United States, included those who are usually underrepresented in service. Step number 3, we have that you have to randomly select your sample, of course. This can be done of 2 ways, as my partner was mentioned, the lottery or the random number method for this sample. It could be used. In the lottery method, you choose the sample at random just by drawing, for example, from a hat, or by using a computer program that will stimulate the same action. In the random number method, you assign every individual number by using a random number generator, or just by giving random numbers. You then randomly pick as a subset of the populations. You can also use the random number function, and also known as A and D in the Microsoft Excel, to generate random numbers, as I was explaining. An example of a random selection of the Census Bureau would be that if they randomly select addresses of 295,000 households monthly, or 3.5 million per year, each address has approximately a 1 in 480 chance of being selected. Step number 4, we have that they collect data. You need to collect data. Of course, you need to do it from your sample. You need to collect data from them. You should take all resources available to collect the data of all the population that you have selected for your investigation, to ensure the validity of your finding. You need to make every individual to participate and select. You need to make sure at the end that they actually participate in your study. If some drop out or do not participate for reasons associated with the questions that you are studying, this could bias your findings. For example, if young participants are systematically less likely to participate in your study, your finding might not be valid due to the underrepresentation of this group. So each member of the people that will be tested needs to be an active participant of your investigation. For example, an example of data collection with the Census Bureau is that they first sent a letter to ask the member to fill the survey outline. If the occupants of an address do not respond, the Bureau calls the home's telephone number. If all else fails, a member of the Bureau visits the address of the person. And as I told you, we need to make sure every member is actually participating. We cannot let anyone behind. Although through this variety of methods, the officials collecting data of the ACS managed to receive responses from 95% of those randomly selected, just by making sure that everyone participates. And of course, in the path there will be someone or there will be always accidents that will be out of our hands, but even if you make sure that everyone participates, you will get an even higher response of 95% of the randomly selected person. A high response rate that supports the validity of your results. And at the end, this is exactly what we are aiming to achieve, right? Thank you for your attention.